This lesson covers the major research designs used in health psychology. This is important because it will help you understand the research that health psychology uses to make the claims that it does. Science relies on empirical evidence, which involves gathering data through observation and experimentation. In health psychology, empirical evidence might include clinical trials, surveys, and physiological, body-based measurements to understand how psychological factors influence health and illness. Empirical research helps in validating theories and hypotheses by grounding them in observable and measurable phenomena. We can show that something is true with evidence. Scientific inquiry is often guided by theories. Theories provide frameworks for understanding complex concepts. Theories are continually tested and refined based on empirical evidence, which helps ensure that scientific knowledge evolves over time. Health psychology uses many research designs to understand how psychological processes affect health. These designs include longitudinal studies, cross-sectional studies, randomized controlled trials, and quasi-experimental studies, just to name a few. Each design has its strengths and limitations, and the choice depends on the research question, practical limitations, and ethical concerns. Descriptive studies focus on describing the characteristics of a population or phenomenon. These studies are observational in nature and do not seek to establish cause and effect relationships. Think of these studies like a screenshot. They help us see and understand the details about a group of people or a particular health issue at one point in time. The main goal of these studies isn't to figure out why something happens, but to carefully observe what is happening. This is useful when we want to know more about people's health conditions, their beliefs, what's trending, or how they behave. Descriptive studies are great for exploring new areas where we don't have much information yet. They help us set up starting points or baselines. These starting points are like markers on a map, showing us where we are now so we can see how things might change in the future. They're important for guiding where we go next in our research. Now, let's talk about two key ideas you'll often hear about in descriptive studies: prevalence rates and incidence rates. Prevalence rates show us how many people in a certain group have a disease at a single point in time. For example, how many people in the United States have depression right now? On the other hand, incidence rates are more like a video, tracking how many new cases of a disease or condition pop up in a group over a certain period, usually a year. For example, how many people in the United States developed depression during the COVID-19 pandemic?
Correlational studies are used to see whether there is a relationship between two or more variables. The key idea here is to find out if these variables change together in a consistent way. In these studies, researchers observe existing conditions without changing anything. For example, think about socioeconomic status, which is a way to describe where people stand in society based on their education, how much money they earn, and the kind of job they have. Can you think of anything that socioeconomic status might be correlated with? When we find a statistically significant correlation between two things, it means there's an interesting and meaningful link between them. It's like discovering a clue that these two things might be related in some way, but it does not mean that we know for sure that one thing causes the other. There are two kinds of correlations we can look at: a direct correlation and a partial correlation. A direct correlation is when we look at how two things are connected without considering anything else. Say, for example, that we look at the relationship between how much someone studies and test scores. We might expect that as someone studies more, that their test scores also tend to increase. A partial correlation is a little different, and it's a little bit confusing because we actually get more information with a partial correlation. So with a partial correlation, we still look at how two things are related, but then we also take into account at least one other factor. So thinking about that example where we looked at how study time and test scores are correlated, well, there are definitely some other things that might impact this relationship, like amount of sleep, which probably also helps test scores improve. I can get a partial correlation by partialing out or removing the relationship that sleep has on test scores. And by doing that, I can get a more pure picture. Because if I know the correlation that sleep has with test scores, then I can take that out of the picture of just how much study time relates to test scores. So then I can get a more pure picture with the influence of sleep and test scores removed from the whole situation. I think we all know what the traditional experiment is, but just to make sure, an experiment lets us test if something causes something else, and it involves an independent variable and a dependent variable. The independent variable is what the researcher manipulates, what they change about the situation. A dependent variable is the variable that we think might be influenced by the independent variable. And then we have something fancy called a quasi-experimental design. And basically the only thing you need to know about that is that a quasi-experimental design does not rely on random assignment. It relies on some already existing difference that there is. And it really helps in cases where it might not be ethical to manipulate a variable. For example, we can't necessarily change someone's diet. But if we got people who were vegans and then people who were not vegans, and we looked at their medical records to see which group of people had higher levels of cholesterol, then that would be a quasi-experimental design, because we're taking advantage of a difference that already exists.